My name is William Kirkendall, Team Leader for Field Applications Engineering here at Reaction Design. Welcome to this video about Forte and knock prediction for IC engines. In this video, I'm going to show you how easy it is to set up a knocking simulation in Forte for an SI engine. In the past, using a detailed chemistry mechanism in CFD was unfeasible, but with today's computing power and advanced CFD tools like Forte, using detailed chemistry in CFD simulations is not only feasible, it is a requirement to get accurate CFD predictions. Let's take a closer look at the conditions for this engine simulation. This example case is a port-injected spark-igniting engine where we consider the fuel to be pre-mixed and pre-vaporized. But we could have modeled the injection event in the port or into the chamber if this were a DI engine. Now let's take a look at the engine setup in Forte. What you see now is the Forte setup user interface. To orient you to the software, the graphics area is located in the middle. On the right-hand side, you have the visibility tree. On the left-hand side is the workflow tree, where the user specifies all of their input conditions for the simulation. You simply work from top to bottom through the workflow tree to set up your simulation. If you forget a setting, Forte will let you know where you forgot the setting in the lower right log window. The next step is to specify the chemistry mechanism we want to use for the simulation, which is really determined by the fuel of interest, whether it be a gasoline or a diesel fuel or a dual fuel type engine. There are several fuel models available with Forte. In this example, we're going to use a gasoline PRF fuel model, which consists of isooctane and N-heptane as the fuel components. The fuel composition used provides an octane number of 87. The PRF mechanism in this case has 178 species, which is considered quite a large chemistry mechanism for most CFD tools, but is considered an average size chemistry mechanism in Forte. This PRF mechanism has been reduced to predict knocking in engines, so it includes the low temperature chemistry that is required to predict the autoignition of the end gas. So we could just click open to import that chemistry mechanism, and then we have the opportunity to view it. Since this is a spark-ignited engine, the spark ignition model should be activated. This is where we will specify the location of the spark, right here, the starting angle, and the duration of the spark event. In this case, the spark timing is 688 crank angle degrees or 32 crank angle degrees before top dead center. You can also set up parameter studies for all Forte inputs. And in this case, we could set up a parameter study for a spark timing suite. Forte has ChemChemPro built inside. In addition to the ChemChemPro chemistry solver, Forte has some unique capabilities to speed up the chemistry solution time even further. Dynamic adaptive chemistry performs a mechanism reduction on the fly, which means Forte uses only the amount of chemistry required for a particular time step. This option is typically only used with very large chemistry mechanisms of 500 or more species, since the base ChemChemPro solver is so fast. So in this case, we would not use the dynamic adaptive chemistry. However, the other unique capability is the dynamic cell clustering, and this option is always used for reacting flow simulations. This option will cluster together cells that are kinetically similar based on temperature and equivalence ratio dispersion. For example, if your simulation has 100,000 cells, the clustering may only result in 1,000 clusters to solve for chemistry. This means the chemistry problem is 100 times smaller, which dramatically reduces computational time. The ability to predict autoignition or pre-ignition lies within the ability of the detailed chemistry to predict these phenomena. But how do we assess if an engine is knocking once we have the chemistry in there? To assess knocking in an engine in Forte, Forte allows you to instrument the model with monitor probes, which are like pressure sensors in the experimental testing. This allows you to sample pressure or any other variable at a particular location in the model and to also write out any output data that you are interested in at that location. In this case, we're primarily interested in the pressure, since we want pressure signal so we can pass it through a bandpass filter to assess the knocking in the engine. Now let's switch over to the Forte visualizer and take a look at the results for this engine simulation. So what we have here is the pressure trace for this engine, and you can see the pressure fluctuations here. That's the red line. The blue line here is the result of passing the pressure trace here through a bandpass filter to compute a knocking index or a knocking intensity. The knocking index allows the user to boil down the knocking of an engine to a single number so that the user can compare different engine conditions to determine if engine A is knocking more than engine B or condition A is knocking more than condition B. So it's a very nice quantity to assess relative knocking between engines or conditions. Now that we've determined that this engine is knocking, we might want to go look at the 3D results to determine where is it knocking. What you see here is a cut plane through the cylinder, just below the head through the piston here. The white and black grid lines where they intersect, that shows where the flame front currently sits. And the contour map you see here is for temperature. So what we should see ahead of this flame front is cool gas. So that would be the N gas. But in this case, we see that the N gas is already auto-ignited ahead of the flame front. So now we could go back and do some further analysis on the engine to determine why is this engine knocking, what is the primary cause for the knocking in this engine. And we could do all of that work in the Forte visualizer, which comes included with Forte. That completes this video on how better chemistry and fuel surrogates allow you to predict knocking in an SI engine using Forte. Thank you for viewing this video. If you have any questions or comments, please feel free to contact Reaction Design by emailing sales@reactiondesign.com for more information. You can always find us on the web at www.reactiondesign.com. We'll be uploading future videos to the website. We look forward to helping you with your simulation needs.